Okay, we're going to start with our Chapter 18 worksheet and covering pediatric dosages. And this was from page, let's see, 537. It's the worksheet. Okay, so today we're going to focus on our pediatric dosages, right? So let's remember two things from your rounding rules right here, number 13 and 14. So when you round weight in pounds and kilograms, you round them to the nearest tenth unless you're doing Chapter 18 and it concerns pediatric calculations. Then you round the weight to the nearest hundredth and you calculate the safe dose ranges also to the nearest hundredths. So 13 and 14, that's where those rules start applying, is in this chapter. Okay, so we're going to round to the hundredths. Then, all right, I think we're good with that for now. And then remember, when we convert 1 kilogram, that's going to equal 2.2 pounds. And that should be all we need to start with for right now. Sorry, guys. Okay, let's do problem 1. The licensed prescriber orders cephalexin 250 milligrams PO 4 times a day for a child weighing 50 pounds. You have cephalexin 250 milligrams per capsule. The recommended daily PO dosage for a child is 25 to 50 milligrams per kilogram per day in divided doses, Q 6 hours. The child's weight is what is the safe and therapeutic range? Is the order safe? And how many capsules will you administer? Okay, so these are all multi-part problems. So the first thing we're going to do is go ahead and take the weight of the child, and in this case, it's 50 pounds, and we're going to convert to kilograms. So 50 pounds, 2.2 pounds to 1 kilogram. And that's going to give us 50 divided by 2.2 is 22.73 kilograms, because again, we're rounding to the hundredths place. Okay. Then we're going to figure the safe and therapeutic range. So in the problem where it says the recommended daily PO dosage for a child is 20 to 50, that's your upper and lower limit, okay, that you're going to figure out, you're going to use that information to figure out what is the safe dosage range for this child that weighs 22.73 kilograms. Okay, so we're going to start with the 25 milligrams per kilogram per day. Okay, we know our child weighs 22.73 kilograms. So our unit in kilograms will cancel here and cancel here. So when you're working on these problems, right, the book is just kind of typing all of the units linearly. So it's milligrams per kilograms per day. Get into the habit of writing your units this way. 25, keep your milligrams on top and put the kilograms per day in the denominator. Because then your units of kilograms here with the weight will cancel. So you're going to get units of milligrams per day, which would be appropriate. Okay, so we're going to take 22.73 and multiply that by 25. And that's going to give us 500 68.25 milligrams per day. And this is our low end of our range. Okay, so then we're going to take the 50 milligrams per kilogram per day, and we're going to multiply that by the child's mass in kilograms. And again, our unit of kilograms is going to cancel. And then we're going to figure what is 50 times 22.73, and that's going to give us 1,136 point, oh, that would look messy, 36.5 milligrams per kilogram. Oh no, just milligrams per day. Our units of kilograms canceled. Okay, so now we need to figure out how much our child is being administered per day. So at the very beginning, the problem statement told us the child is going to be administered 250 milligrams, right? That's their single dosage order, but they're going to be given that. Remember, like for the most part, we've been kind of ignoring the frequency. Now we are going to start using the information regarding frequency. So the order is 250 milligrams, and the problem is telling us that the frequency is 4 times a day. So we're going to have 4 doses per day. So there's 250 milligrams per dose, and there's 4 doses per day. So your unit of dose is going to cancel. So 250 times 4 is 1,000 milligrams per day. And this is based on the doctor's order. Okay, and then this information is the high end of your safe and therapeutic range. So what it's asking you in part C is the order safe? Okay. Hey guys, let's take a, I'm sorry, it's a morning. Let's take a quick like 10-minute break, okay? And I'll be right back. I'm sorry, I need to take care of something really quick. Okay. Okay, so okay, now we have one more part to complete. So the doctor's original order, right, is 250 milligrams. We know that we have available a dosage strength of 250 milligrams per capsule. So our units of milligrams are going to cancel. 250 divided by 250 is just 1 capsule. Okay, so this is where this chapter, you just have to keep track of all the pieces of information. Okay, so the first part is always going to be to convert the child's weight from pounds to kilograms. And then you're going to figure what your safe and therapeutic range is. So the problem statement told us the daily recommended dosage for a child is 25 milligrams to 50 milligrams per kilogram per day. So then we calculate our low end of our range and then our high end of the range. Next, we have to figure, based on the doctor's order and the frequency, how much would you be medicating your child in that 24-hour period? Okay, and so again, the problem told us 24 milligrams per dose, and we're going to administer 4 doses to the child in a day. So this gives us how much medication we're going to administer throughout a 24-hour period. And then we take this value and we compare it to our high our low and our high end of the safe and therapeutic range. If this number is in between your low end and your high end, it is a safe and therapeutic dose. Okay? Then, if this is safe, then you calculate based on the doctor's order and our dosage strength what we would administer to our patient per dose. So this is what we've been doing, right? This is just all an extension of that. And again, be sure when there are trailing decimals for this chapter, you are rounding to the nearest hundredths place. Okay, so let's answer problem 1. The child's weight is 22.73 kilograms. What is the safe and therapeutic range for this child? The safe and therapeutic range is from 568.2 milligrams per day to 1136.5 milligrams per day. Then, is the order safe? Yes. Based on the doctor's order and the frequency, the patient will be administered in a 24-hour period a safe and therapeutic dose because it's within this range. And if yes, how many capsules will you administer? So the doctor's order, the dosage strength, will administer 1 capsule per dose. So they're still asking, that last question is still based on the single dose, not for the entire day, just 1 single dose. Okay? Let me know if you guys have any questions or if you're getting stuck, because I know there's a lot of little pieces to these questions. Okay, so then number 2, the licensed prescriber orders digoxin 12.5 milligrams PO daily for an infant weighing 6 pounds, 8 ounces. You have digoxin 0.05 milligrams per milliliter. The recommended dose for an infant is 0.035 to 0.06 milligrams per kilogram per day in divided doses 2 times a day. The child's weight is, okay, so again, we are going to figure how much the child weighs in in kilograms. So the first thing is their weight. It's 6 pounds, 8 ounces. Okay, and remember, 16 ounces equals 1 pound. So 8 ounces equals a half a pound. So a child that weighs 6 pounds, 8 ounces is 6.5 pounds. So we're going to convert 6.5 pounds to kilograms. So 2.2 pounds per 1 kilogram. Our units of pounds are going to cancel. 6.5 divided by 2.2. Our child weighs 2.95 kilograms. Okay, and then we're going to figure the low end of our safe and therapeutic range. So that's going to be 0.035 milligrams per kilogram per day. We're going to multiply that by our 2.95 kilograms. And that's going to be 0.035 times 2.95 is going to equal 0.1 milligram per day. And this is our low end of the range. Then we're going to take our, 0.06 milligrams per kilogram per day. And again, multiply it by the child's mass, kilograms will cancel. And then 0.06 times 2.95. And that's going to give us 0.18 milligrams per day. And that's the high end of the safe and therapeutic range. Okay, now we figure out how much we're administering to the child based on the doctor's order. So the doctor's order is 12.5 milligrams daily. So is this within the safe and therapeutic range? Anyone? Hello. Okay. The doctor is ordering 12.5 milligrams per day, and that is significantly more than 0.10 milligrams per day or 0.18 milligrams per day. So this doctor's order would not be safe and therapeutic for an infant. So you would answer not safe. And then part D, if yes, how many milliliters will you administer? You wouldn't administer anything to the child because this order is not in the safe and therapeutic range. So do not administer. You would either talk to the head nurse or you would confirm this order with the doctor. Okay? Okay, number 3. The licensed prescriber orders diphenhydramine 25 milligrams IV/Q 6 hours for a child weighing 50 pounds. You have available diphenhydramine 12.5 milligrams per milliliter. The recommended daily dose for a child weighing more than 12 kilograms is 5 milligrams per kilogram in a 24-hour period in 4 divided doses. Okay, so your child weighs 50 pounds. We're going to convert that to kilograms. That's 2.2 pounds per kilogram. 50 divided by 2.2 is going to be 22.73 kilograms. Okay, then so the child is 22.73 kilograms, and they gave us a daily dose for a child weighing more than 12 kilograms. So this would apply to this child because they meet that requirement. And the dosage range is 5 milligrams per kilogram in a 24-hour period. So in a day. Okay, so we'll multiply that by 22.73 kilograms. Our units of kilograms will cancel. And we're going to take 5 multiplied by 22.73. And that is going to give us 100. Okay, 113.65 milligrams per 24-hour period. Okay, then we also know that the doctor is ordering that this is divided in 4 doses. So we're going to take this answer and divide it by 4. So that's going to give us 28.41 milligrams per dose. Okay? And let's see. The licensed prescriber orders, going back to the original statement, the licensed prescriber orders diphenhydramine 25 milligrams IV Q6 hours for a child. So that order, that single dose order is only 25 milligrams. So it does not exceed this daily threshold. So the 25 milligrams IV is a safe order. And so because it is safe, then we're going to take the doctor's order and multiply it by the dosage strength of 12.5 milligrams per milliliter. Our units of milligrams are going to cancel. And we're going to take 25 divided by 12.5. And that's going to give us 2 milliliters to administer to our patient. Did everybody understand this problem? Because it has a different frequency setup. Instead of telling us a high and a low, the problem just tells us a daily maximum, right? So 5 milligrams per kilogram in a 24-hour period. We use our weight to find out how much we can administer to our child in a 24-hour period. But because the recommended dosage and the doctor's order tells us to administer our medication to the patient in 4 doses in a single day, we take this daily measure, we divide it by 4 so that we can find our single dose administered to a student. This is going to be to a patient. So this is going to be the maximum that you can administer a patient that weighs 22.73 kilograms in a single dose. So then we compare that to the doctor's order, which is 25 milligrams. This order does not exceed this maximum for the single dose. So this is a safe and therapeutic dose. And then we just calculate what we would administer to our patient like we normally do. Okay? So then the next question is calculate the 24-hour maintenance fluids for a child who weighs 28 pounds. Okay, so the first thing you're going to do is, again, convert 28 pounds to kilograms. And that's going to be 12.73 kilograms. Okay, and then you're going to have to look at the chart on page, let me see. It's on page 533 in your book. And that chart shows you how to calculate fluid maintenance. So it's how much fluid you should be receiving based on your mass in kilograms, okay? So our patient weighs 12.73 kilograms. So for a patient that weighs 0 to 10 kilograms, you automatically administer 100 milliliters per kilogram, okay? Then once that weight increases further into the greater than 10 to 20 kilograms, you calculate 1,000 milliliters plus 50 milliliters per kilogram for the mass over 10 kilograms. Okay, so we're going to take our mass, 12.73, subtract 10, because this is our threshold, 10 kilograms, and the mass over that, over the 10 kilogram threshold, is a remaining 2.73 kilograms. Okay, so because our patient is in the greater than 10 to 20 kilogram mass, we use this formula. Okay, so we automatically start with 1,000 milliliters plus 50 milliliters per kilogram, and this, you multiply this part of the formula by the mass over 10 kilograms. So we're going to multiply this by 2.73 kilograms. Our unit of kilograms comes out, cancels there, and then we're going to take 50 times 2.73, and that's going to give us 136.5 milliliters. And then we're just going to bring this 1,000 down and add these two values together. So that's going to be 1,136.5 milliliters per day. Okay, and so this is your daily fluid maintenance requirement for an individual that weighs 28 pounds. Next one, the licensed prescriber orders 70 milligrams PO twice a day for a child weighing 22 pounds. 5. The child weighs 22 pounds. We're going to convert that. Okay, so 22 divided by 2.2 is going to give us an even 10 kilograms. Then the recommended dose is 14 milligrams per kilogram in a 24-hour period. Okay, so again, it's telling us our daily maximum. So it's 14 milligrams per kilogram in 24 hours. We're going to multiply that by 10 kilograms. So that's going to be 140 milligrams per 24-hour period, or in a single day. Okay, then we also know that this medication is administered twice a day, right? So this is our daily maximum. So we're going to divide this by the 2 doses so we can find out what our single dose rate is going to be. So 140 divided by 2 is 70 milligrams per dose. Okay. And our original order is 70 milligrams PO twice a day. So the doctor's order is right at the maximum. So yes, that is still within the safe and therapeutic range. So we would administer our medication to the patient. So again, we start with our doctor's order, 70 milligrams, and our dosage strength is 125 milligrams per 5 milliliters. And let's see, 70 times 5 divided by 125 is going to give us 2.8 milliliters. So the 2.8 milliliters is what's going to be administered per dose. Okay, number 6. The licensed prescriber orders Ciprofloxacin, 300 milligrams, Q, 12 hours, PO for a child weighing 30.3 kilograms. So yay, they gave us the weight in kilograms. We don't have to convert that. You have ciprofloxacin, 250 milligrams per 5 milliliters. The recommended oral dosage is 20 to 30 milligrams per kilogram per 24-hour period. Q, 12 hours. Okay, so our orders on our high and our low and our high for this is going to be 20 milligrams per kilogram per day, right? Or in a 24-hour period. And the high end is 30 milligrams per kilogram per 24-hour period. We're going to multiply that by our mass of 30.3 kilograms. And we're going to cancel our units of kilograms. Okay, so 20 times 30.3. Aaron. Yes. Okay, so 20 times 30.3 is an even 606. No. Oh, okay. It sounds like it. Okay. All right. Then the high range is going to be 30 times 30.3, and that's going to equal 909 milligrams in a 24-hour period. And this is milligrams in a 24-hour period. Okay. Okay, so this is your daily, right? But then the problem tells us the doctor is ordering 300 milligrams Q 12 hours, and then in the recommended oral dosage, it also tells us administer Q 12 hours. So this is daily low and this daily high would be divided by 2 because you're going to administer 2 doses in that 24-hour period. So 606 divided by 2 is going to be 303 milligrams per 24-hour period. Oh, I'm sorry. 303 milligrams per dose, per single dose. Okay, and then the same thing, you'll take 909 and divide it by 2, and that's going to give you 454.5 milligrams per dose. Okay, and then let's go back to the doctor's original order. The doctor's original order is 300 milligrams Q 12 hours. So in the single dose, the doctor is ordering 300 milligrams. So I would say this is not within the safe and therapeutic because it's right right, the lower threshold, but your book says it's within the safe and therapeutic range. So I'm going to show you the last step. So we go back to the doctor's original order of 300 milligrams, and we multiply that by the dosage strength, and our dosage strength is 250 milligrams per 5 milliliters. So our unit of milligrams cancel. It's going to be 300 times 5 divided by 250. And that's going to give us 6 milliliters. I guess because this problem didn't actually ask is the dose safe and therapeutic? It just asks, what is the safe and therapeutic range for a 24-hour period? So there's our 24-hour period, safe and therapeutic range, and then they ask, what is the single dose range? So we took these values, divided them by 2, and that's your single dose range. So it didn't ask if it was safe or therapeutic. And then the last part is how many milliliters are needed to deliver the ordered dose. So again, the order times the dosage strength, you'll administer 6 milliliters to your patient of this medication. All right, number 7. The licensed prescriber orders prednisolone 45 milligrams twice a day PO for an asthmatic child weighing 94 pounds. So, you know, the kid weighs 94 pounds. That just looked messy. Per kilogram. $94 divided by 2.2, it's going to give us 42.73. Okay, and that's going to be in kilograms. Okay, so then the recommended oral dosage is 0.5 to 2 milligrams per kilogram in a 24-hour period, divided twice a day. Okay, so the low end is 0.5 milligrams per kilogram per day, or per 24-hour period. And then the high end is 2 milligrams per kilogram per 24 hours. So we're going to multiply both of these values by our mass in kilograms. 42.73 kilograms. Our units are going to cancel. Sorry, so 0.5 multiplied by 42.73 is going to equal 21.37 milligrams per 24-hour period. And then our high range is going to be 42.73 times 2, and that's going to give us 85.46 milligrams per 24-hour period. And we're going to take both of those and divide by 2 so we can get our single dose range, okay? So 21.37 divided by 2, it's going to be 10.69 milligrams per dose. And 85.46 divided by 2 is going to give us 42.73 milligrams per dose. Okay. So this is our low end of our range and the high end of our range for a 24-hour period. And then this is the low end and the high end of our safe and therapeutic range for our single dose. So then we go back and we look at the doctor's order. The doctor's order is 45 milligrams twice daily. So is this in the safe and therapeutic range? No, because 45 milligrams per dose is higher than the upper limit of your range for the safe and therapeutic single dose. So again, the doctor's ordering 45 milligrams. It's not safe and therapeutic. And so you would, again, you would either talk to the doctor or the head nurse on how to proceed before you administer any medication to your pediatric patient, okay? And number 8, I should have enough. Okay, the licensed prescriber orders Phentoin 60 milligrams POQ 12 hours for a child weighing 40 pounds. So again, 40 pounds, convert to kilograms. 40 divided by 2.2 is going to give us 18.18 kilograms. The recommended oral dosage for a child is 5 to 7 milligrams per kilogram in a 24-hour period. So again, let's set up our work. 5 milligrams per kilogram per 24 hours. That's our low end of the range, and 7 milligrams per kilogram per 24 hours. So that's the high end. We take both of these and we're going to multiply them by our mass. Our units of kilograms are going to cancel. So 5 times 18.18 is 90.9. Okay, and then 7 times 18.18 is going to give us 127.26 milligrams per 24 hours. Okay, and again, this medication is divided into 2 doses since the frequency is Q12 hours. So we're going to go ahead and divide both of these by 2. So 90.9 divided by 2 is going to be 45 milligrams per dose. And then 127.26 divided by 2 is going to be 63.63 milligrams per dose. Okay, then going back to the original doctor's order, the doctor is prescribing 60 milligrams to this child. So the child's weight is 18.18 kilograms. This is your safe and therapeutic range for the 24-hour period. The doctor's order is 60 milligrams. So you compare it to the single dose range, and 60 milligrams is within the safe and therapeutic range. So the order for 60 milligrams is safe. So we go back and calculate what we would administer to our patient. So our doctor's order is 60 milligrams, and we have available, our dosage strength is 30 milligrams per chewable tablet. So our units of milligrams is going to cancel, trailing zeros cancel, so 6 divided by 3 is 2 tablets. So there's your child's weight. There's your 24-hour safe and therapeutic range. There's your single dose safe and therapeutic range. The doctor's order is 60 milligrams, so it's within the safe and therapeutic range. And then we calculate how many tablets we would administer to our patient. Okay, number 9. A child is to receive vancomycin 750 milligrams IV PB Q6 hours. The child weighs 68 pounds. The recommended dosage of vancomycin is 40 milligrams per kilogram per 24-hour period to 60 milligrams per kilogram 24-hour period. Okay, so let's convert the mass first. So 68 divided by 2.2 is going to give us 30.91 kilograms. And we take both of these and we multiply them by 30.91 kilograms. Our units of kilograms are going to cancel. And then we take 40 times 30.91, and that's going to give us 36.4 milligrams in a 24-hour period. And 30.91 times 60 is going to give us 1854.6 milligrams in a 24-hour period. Okay, so then the order is Q 6 hours, right? So your frequency for your order is Q 6 hours. So this daily range is going to be divided by 4 doses. So if I'm administering my medication to my patient every 6 hours, I'm going to administer 4 doses in a 24-hour period. So I'm going to take both of these values and divide them by 4. So this is going to be 3309.1 milligrams per dose. And then 1854.6 divided by 4 is going to give us 463.65 milligrams per dose. Okay, then let's go back and check the doctor's order. The doctor's order is 750 milligrams, so that's your single dose order. So 750 milligrams IV PB. So this is your low end and your high end for your single dose range. The doctor is ordering 750 milligrams. So 750 milligrams is way above this upper limit for your dose. So you would not administer. So part C, is the order safe? No. The 750 milligram order is not safe. Excuse me, guys, I'm like really congested today. Okay, the license, number 10, the licensed prescriber orders amoxicillin 300 milligrams PO Q 12 hours for a child weighing 42 pounds. You have amoxicillin available as 125 milligrams per 5 milliliters. The recommended oral dosage is 25 to 50 milligrams per kilogram in a 24-hour period, Q 12 hours. So 25 milligrams per kilogram, 24 hours, 50 milligrams per kilogram in 24 hours. Again, this is our low end of our range. This is the high end of our range. We're going to convert our pounds to kilograms. So 42 divided by 2.2 is 19 point, I would leave it 19.09. kilograms. Okay, and then we're going to take our 19.909.09 kilograms. I'll multiply that to the low and the high end of our range. Our units of kilograms will cancel. So 19.09 times 25 is 477.25 milligrams per 24-hour period. And then 50 times 19.09 is going to give us 954.5 milligrams per 24-hour period. Okay, and then this is your daily, and the dosage frequency is Q12 hours. So we're going to divide this by 2. This comes out to 477.25 milligrams per dose. And then 477.25 divided by 2 is 238.63 milligrams per dose. Okay, then we compare the doctor's order. So the doctor's order is 300 milligrams every Q12 hours. So it's the single dose order, and that would be within our safe and therapeutic range. So we would figure out how many milliliters to administer. So the doctor's order is 300 milligrams. Our dosage strength that we have available is 125 milligrams per 5 milliliters. So 300 times 5 divided by 125 is going to give us 12 milliliters to administer to our patient. Okay, number 11. The licensed prescriber orders 100 milliliters D5W bolus IV to run over 30 minutes to a 3-year-old child. The drop factor of the tubing is 60 drops per milliliter. How many drops per minute are needed to deliver the bolus? Okay, so again, we focus on the volume being administered. That's 100 milliliters. And we look at the time frame. That's 30 minutes. And our tubing factor is 60 drops per milliliter. And we also, our units are drops per minute. So our units of milliliters are going to cancel here. We have trailing zeros, cancel there. So 10 times 60 is going to be 600. And then divided by 3, it's going to give us 200 drops per minute. Okay. And then number 12. The licensed prescriber orders carbamazepine 150 milligrams PO 3 times a day for a child weighing 58 pounds. Okay, you have carbamazepine, I don't know, 100 milligrams per 5 milliliters available. The recommended oral dosage for a child is 10 milligrams per kilogram in a 24-hour period. And the high end is 20 milligrams per kilogram in a 24-hour period. So again, we're going to convert our mass to kilograms. So 58 divided by 2.2 is 26.36 kilograms. And then we're going to take both of our low and our high end and multiply them by our mass. Kilograms. Okay, so 26.36 times 10 is going to give us 263.6 milligrams in a 24-hour period. And the order frequency, let me look, is 3 times a day. So divide this by 3. That's going to give us 87.87 milligrams per dose. And then 20 times 26.36 to give us our high end of the range. And that's going to be 527.2 milligrams per 24-hour period. Then we're going to divide this by 3, and that's 175.73 milligrams per dose. Okay, then let's compare the doctor's order. So the licensed prescriber orders 150 milligrams. So that's within our safe and therapeutic range. So how many milliliters will we administer? So you take the doctor's order times your dosage strength, which was 100 milligrams per 5 milliliters. So we have cancel a trailing 0. We can cancel our milligrams. So that's going to be 15 times 5 divided by 10. And that's going to give us 7.5 milliliters. Okay. And number 13. To calculate the 24-hour maintenance fluid requirements for a child who weighs 72 pounds. So 72 pounds. So it's one of these fluid maintenance problems again. We're going to convert our mass first. So 72 divided by 2.2 gives us 32.73 kilograms. We're going to go back to the chart on, what was that? 533. So this individual is in the greater than 20 kilograms range. And the formula there is 1,500 milliliters plus 20 milliliters per kilogram over 20 pounds. Okay, so we're going to take this number minus 20, and that's going to give us 12.73 kilograms. This is what is over 20 pounds. Okay, so the fluid maintenance requirement for someone that weighs over 20 kilograms, so we find how much mass is over 20 kilograms because we're going to need that value. Okay, we start off with the 1,500. We keep that, and then this 20 milliliters per kilogram gets multiplied by the 12.73. Excuse me. I haven't been outside today, but it sounds really windy and like there's fall weather outside, and my allergies are going crazy. I apologize, guys. Okay, so we're going to take 20 milliliters times the 12.73 times 12.73, and that's going to give us 254.6 milliliters. And then we're going to add the 1,500 milliliters. And that's going to be a total of 1,754.6 milliliters for the individual's daily fluid maintenance requirements in a 24-hour period. Oh, and it also wants you to calculate how many milliliters per hour are needed to deliver the maintenance fluid. So this is your fluid in a 24-hour period. So just take that value and divide by 24. And that's going to give you 73 what's going to come out to 73.1 milliliters per hour. So we're going to round this to the whole number. So that's going to be 73 milliliters per hour. So you'll set your patient's pump at 73 milliliters per hour on a IV drip in order to reach their daily fluid maintenance requirements. Okay, number 14. The licensed prescriber orders ibuprofen 100 milligrams for a child that weighs 52 pounds. So let's convert our mass. The recommended dose for ibuprofen is 5 to 10 milligrams per kilogram per dose, Q 6 hours. Okay, so 5 milligrams per kilogram per dose to 10 milligrams per kilogram per dose. Okay, so let's figure the mass first. 52 divided by 2.2. That's 23.64 kilograms. And then we're going to multiply that to our high and our low range. Our units of kilograms are going to cancel. And we're going to take 5 times 23.64. And that's 118.2 milligrams per dose. And then 10 times 23.64 is going to be 236.4 milligrams per dose. Okay, so the child's weight, the safe and therapeutic single dose range for this child, the doctor ordered 100 milligrams. It doesn't ask if that order is safe. So we're just going to calculate how many milliliters are needed to deliver the ordered dose. So the ordered dose is 100 milligrams. The dosage strength is 100 milligrams per 5 milliliters. Milligrams cancels, trailing zeros cancel. So you're left with 5 milliliters is your dose administered. Again, it doesn't ask us if this is safe and therapeutic because it is slightly below the low end of our range. So while it may be safe, it's not necessarily therapeutic, but we don't know. And it asked us to go ahead and calculate it. So again, I wouldn't do that, but your book does it. Okay, 15. The licensed prescriber orders cefazolin 350 milligrams PO Q6 hours for a child weighing 81 pounds. You have cefazolin 500 milligrams per 5 milliliters. The recommended daily oral dosage is 25 to 50 milligrams per kilogram per 24-hour period. And the child weighed 81 pounds. Okay, so convert your mass. So 81 divided by 2.2, that's going to give you 36.82 kilograms. This is 25 milligrams per kilogram in a 24-hour period. And you're going to multiply it by your mass of 36.82 kilograms. Kilograms to cancel. And the same thing for the high end of the range. You're going to multiply 36.82. Okay, so 25 times 36.82 is going to give us 920.5. The order frequency is Q6 hours, so this would be administered 4 times a day. So we'll divide it by 4 to get our single dose order. It's going to be 230.13 milligrams per dose. And this is milligrams per 24 hours. Okay. And then the high end of the range, it's 50 times 36.82. And that's going to be 1841 milligrams per 24 hours. And again, we'll divide that by 4. And that's going to be 460.25 milligrams per dose. Okay, safe and therapeutic. Okay, then this question asks us, is the order safe? The original doctor's order is 350 milligrams. So that 350 single dose order is within the safe and therapeutic range. So then we go ahead and calculate how much medication to administer. So the order is 350 milligrams. Our dosage strength is 500 milligrams per 5 milliliter. Milligrams cancel, a trailing 0 cancels. So 35 times 5 divided by 50 is going to give us 3.5 milliliters. Okay, number 16. Okay, the licensed prescriber orders cimetidine 60 milligrams POQ 8 hours for an infant weighing 16 pounds. So we'll convert that to kilograms. The recommended daily oral dose is 15 milligrams per kilogram per 24 hours. Divided Q8 hours, so that would be 3 doses in a day. The high to our range is 20 milligrams per kilogram per 24 hours. So let's convert our pounds first. And that's going to give us 7.27 kilograms. We're going to use that for both our high and our low of our range. Our units of kilograms are going to cancel. Okay, so 15 times 7.27 gives me 109.05 milligrams per 24-hour period, but we're going to divide that by 3 to get our single dose. And that's going to be 36.35 milligrams per dose for the low end of our range. And then on the high end, it's 20 times 7.27. That's going to give us 145.4 milligrams per 24 hours. Divide that by 3, and that's going to be 48.47 milligrams per dose. Okay, and the doctor's order is 60 milligrams. So the order isn't safe, but they still want you to calculate how many milliliters you would administer if the dosage strength. Okay, hold on. So we did part A. A, what is a child's weight in kilograms? 7.27. What is a safe and therapeutic dosage range for this child? So there's our daily dosage safe and therapeutic range, and then there's our single dose safe and therapeutic range. The doctor's order is 60 milligrams. So is the order safe? No, the order is not safe. D, how many milligrams per kilogram per 24 hours is the child receiving? So we go back to the doctor's original order. See, this is a different problem. It's asking you extra parts that really wouldn't make sense, because if C is no, it's not safe and therapeutic, then you really wouldn't calculate the rest of it, because you're not going to administer that to a child, but your book wants you to calculate it anyways. Okay, so how many milligrams per kilogram per 24 hours is the child receiving if they follow the doctor's prescribed order? So the doctor's prescribed order is 60 milligrams. Excuse me, milligrams per dose. You know that based on the order frequency, Q 8 hours, the patient is going to receive 3 doses per day. Okay, so your unit of doses are canceling. Then you also know the mass of the child. Actually, you know what? It doesn't matter. It's okay. But the mass goes in the denominator. So 16 pounds goes in the denominator. So I guess you can kind of think about it in a ratio. So that patient is receiving 60 milligrams per 16 pounds. Again, this chapter, it's a lot of units to keep track of. Okay, so then convert this pounds to kilograms. That's going to be 2.2 pounds per kilogram. Pounds are going to cancel. Yeah, and all of your units are going to work out. Okay, so 60 times 3 times 2.2, and then divide by 16. 24.75 milligrams per kilogram per day. Okay, so if we calculate how much medication we would be administering to our patient based on the doctor's order, what you're basically trying to do is make your end units match the units that we typically start with as part of our high and our low end range, right? So I know that my doctor's order is telling me to administer 60 milligrams per dose. My frequency, Q8H, is telling me that I'm going to administer 3 doses per day, or 3 doses in a 24-hour period. My child weighs 16 pounds, and I'm going to convert my 16 pounds to kilograms. So my units of dose are going to cancel, and my units of pounds are going to cancel. So at the end, I have units of milligrams per kilogram per day. There's my milligrams, there's my day, there's my kilograms. So milligrams per kilogram per day. So based on this doctor's order, this ratio is higher than this safe and therapeutic dosage range. So again, this dose is still not safe. Okay, and then the last part, E, if the ordered dosage is safe, how many milliliters will you administer? Again, we already said it's not safe in part C, so part D just reconfirmed that this is not safe because it's higher than the high end of our daily recommended range. So E, again, this is not safe, so we would not administer. We would speak to the doctor. We would not administer. We'd speak to the doctor, we'd speak to the nurse, we'd talk to somebody before we move forward with our pediatric patient. Okay, number 17. Sorry, my keyboard's kind of in my way. Okay, 17. The licensed prescriber orders prednisone 8 milligrams PO Q12 hours for a child weighing 19 pounds. You have prednisone syrup available with the dosage strength of 5 milligrams per 5 milliliters. The recommended oral dosage is 0.5 milligrams per kilogram per 24 hours. 2 milligrams per kilogram per 24-hour period. Given once daily or divided and given in 2 doses per day. The doctor's order told us POQ 12 hours. So after we figure out our daily lower and upper limit of our range, then we're going to divide by 2 since it's Q 12 hours. Okay, so 19 divided by 2.2 is going to give us 8.64 kilograms. 8.64 kilograms. Okay, and then we're going to take that 8.64 and multiply it by 0.5, and that's going to give us 4.32 milligrams per 24 hours. And then we're going to divide that by 2, and that gives us 2.16 milligrams per dose. It's just messy. Okay, same thing for the upper limit. 2 times 8.64 is going to give us 17.28. milligrams per 24 hours. That's our high limit. We're going to divide that by 2, and that gives us 8.64 milligrams per dose. Okay, so then the doctor is ordering 8 milligrams POQ 12 hours. So that means, is the 8 milligrams within the safe and therapeutic range for the single dose? Yes, it is within the low and the high of our safe and therapeutic range for the single dose. So then it is safe. So then we should calculate how much medication we would actually administer. So the doctor's order, and then the dosage strength is 5 milligrams per 5 milliliters. This is 17. So that's going to cancel, milligrams are going to cancel. So we would administer 8 milliliters of the medication to our patient. Okay, 18. The licensed prescriber orders cefazolin 400 milligrams IV Q8 hour for a child weighing 32 pounds. You have cefazolin 330 milligrams per milliliter. The recommended daily IV dosage for a child is 100 milligrams per kilogram in a 24-hour period in divided doses Q6 to 8 hours. Okay, so when you have something like that, where it's telling you the recommended daily dose and then the frequency has a range, Q6 to 8 hours, you go back and you look at the doctor's order and look at the frequency in the doctor's order. So the doctor's order frequency tells us Q8 hours. So we want a dose administered every 8 hours, which means 3 doses given in a day. Okay, so we're going to take 100 milligrams per kilogram in a 24-hour period. And then we'll divide this by 3 in order to get our single daily dose. Okay, so 32 divided by 2.2 pounds to get our mass in kilograms. And that's going to be 14.55 kilograms. Our units of kilograms will cancel here. 0.55 times 100. And that's going to give us 1455 milligrams in a 24-hour period. But we're going off of our doctor's order frequency, Q8H. So we're going to divide that by 3, and that's going to give us 485 milligrams per single dose. Okay, so the doctor's order is 400 milligrams. This is our daily maximum, right? So if the doctor's order is 400 milligrams per dose, is that more than our daily maximum? It's not more. So it is, the order is safe, but we don't know if it's therapeutic. We don't know if this needs to be exact, but we know it hasn't gone over it, so it's not unsafe. So yes, this order is safe at 400 milligrams per dose. So then we need to figure out also how much we would administer to our patient. So our order is 400 milligrams. And then our dosage strength is 330 milligrams per milliliter. So trailing zeros, units of milligrams, cancel. We're going to take 40 divided by 33. And that's going to give us 1.2 milliliters to administer to our patient. Does this make sense to everyone? Right? Because on this problem, we don't have a range. We just have that daily maximum again. So once we figure out what our daily allowable maximum is based on our weight, then we can divide that by 3 based on our doctor's order frequency, so we can get the daily single dose. And now we compare this to our doctor's actual order, which was the 400 milligrams. So this 400 milligrams does not exceed the daily maximum single dose range, so it's safe. So then we can move forward and calculate how much medication we would actually administer to our pediatric patient. Okay? Now,
will it ever say it's minimum?
no, like it's never, like it usually doesn't give you, when we have the ranges, right? This is our daily dose, single dose minimum. This is our daily minimum. This is our daily maximum. This is our single dose maximum. So you kind of have to make sure you're keeping track of that, because they're not just going to outright like say it for you. So like this one has the range, right? Number 17 had a range. 18 doesn't have a range. It's just telling us this in a 24-hour period. So we have to remind ourselves that we are supposed to assume that this is the daily maximum. So as long as we don't go over this daily maximum, then it would be considered safe. But we don't know necessarily that the dose would be therapeutic because we don't know what the minimum threshold is, right? They didn't tell us the minimum. So we always assume if they give us just one of these ranges, this is your daily therapeutic maximum.
Okay, thank you.
Yeah, so I'll tell you at the end when I'm done. Okay, so then 19, the order is to infuse 250 milliliters of D5W over 3 hours to an 11-year-old child. How many milliliters per hour? So the volume, 250 milliliters. The time period is 3 hours. And we're just going to divide that. 250 divided by 3 is 83.3 milliliters per hour. Again, we round to the whole number. So this is going to be 83 milliliters per hour. Yeah, because it's an IV pump. It needs to be rounded. Okay, number 20. It's just regular. Okay. A 25 kilogram child has an order for gentamicin 40 milligrams IV PB twice a day over 20 minutes. The concentration of the vial states 10 milligrams per milliliter. The recommended infusion concentration is 2 milligrams per milliliter. How many milliliters of medication will provide 40 milligrams of gentamicin? Okay, so we are going to administer, the doctor's order is 40 milligrams. We know our dosage strength, or the concentration of the vial, is 10 milligrams per milliliter. So 10 milligrams per milliliter. Our dosage strength, our milligrams cancel, our trailing zero cancels. So we would administer 4 milliliters of medication. Okay, so part B, how many milliliters of IV solution need to be added to the medication to equal the recommended final concentration? Okay, so we are provided the 40 milligrams of gentamicin. So we start with the 40 milligrams. we want to end up with a concentration of 10 milligrams per milliliter. So we need to figure out how much of an IV solution we would need to add to our medication. This is what we have. We have 40 milligrams over X. We want to get a concentration of 10 milligrams per milliliter per one. Okay, so remember we did a problem like this at the very beginning when we were reviewing. I'm trying to solve for this X. So what I need to do is flip both sides of my fractions so I can make my life easier. So I'm going to flip both sides over 40, and I'm just going to rewrite it. 1 milliliter over 10 milligrams. Okay, so I flip this fraction and then I flip this fraction. Now I want to get this 40, this X milliliters, my unknown, by itself. So I need to multiply both sides by 40 milligrams. So this 40 milligrams is going to cancel, and my units of milligrams are going to cancel. Oh, you know what? No. Right concept, wrong measure. Yeah, scratch through that. No, that was wrong. They want us to compare it to the recommended infusion concentration. Okay, sorry, I just reread that. The recommended infusion concentration is 2 milligrams per 2 milliliters. So that's what we should be comparing it to. I'm sorry, guys. So it's still the same setup. It just, we're comparing it to 2 milligrams per 1 milliliter. So still flip it over 40. 1 milliliter over 40. Sorry. Okay, now we want to solve and move this 40 milligrams. So we multiply that to both sides of our fractions in the numerator so that this can cancel here. And then this unit of milligrams cancels this unit of milligrams. Okay, so now we have X milliliters equals to 1 times 40, which is 40, divided by 2, which gives us 20 milliliters. So we need to add 20 milliliters of solution in order to get this ratio. So if I have 40 milliliters and I add 20, y'all, I need more coffee today. Okay, if I have 40 milligrams and I add 20 milliliters, my zeros are going to cancel, and 4 divided by 2 is 2 milligrams per 1 milliliter. So I need to add this much IV solution in order to achieve this ratio. And I can confirm that with my math. My original amount of medication divided by the volume of solution that I need to add in order to get this infusion concentration. Okay, and then the last part of question 20 is how many drops per minute should be infused. Okay, so we know that we're administering, let me see. We're adding 20 milliliters, right, of our solution. So that's the volume are 20 milliliters that we just calculated in the last part. We're administering that over 20 minutes, and we have a I'm not seeing their flow rate. Oh, you know what? I think this is because it's a standard. I think this is something you are just supposed to know. Because it's an infusion, I think you're just supposed to know it is 60 drops per milliliter for an infusion. So then milliliters will cancel, or zeros cancel, and you're just left with 60 drops per minute. Yeah, I think you're supposed to know this ratio. For an infusion, your standard is 60 drops per minute per milliliter. Number 20 is a good practice problem. I would circle it and I would come back to it and make sure you understand all the parts, because I know we really haven't done any problems where you're calculating and figuring out what volume of solution you're going to need in order to achieve this concentration. And that's all of the worksheet, guys. Stop recording.